important senses for us because it is one of our most developed senses. We can see color, we can see lightness and darkness, we can see depth. That means how far away something is. It's very easy for us to see that. We have very highly developed sense of sight. Now, in your eyeball, there are these parts called rods and cones. Now, rods are responsible for seeing lightness and darkness. When I'm in a room and I can see, hey, it's light in here, that's my rods working, okay? What do you think cones are responsible for? Well, they're responsible for color. Cones are responsible for seeing the entire, we call it the visible spectrum of light. All the colors that are possible we can see because of our cones. Now there are certain people who can't see color. We call that being color blind. Now normally you might think of light as white. The light that comes from the sun is really no color at all. It's just white. If I see a light from a flashlight, it's white. We think of light as white, but actually for something so hot, the sun is pretty cool. Because what the sun can do is the sun has all the different colors of light inside that light. Now when you see a color, that's not because that object is absorbing that color. It's not like my shirt is going, yum, 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 orange. No, it's actually going, yum, 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 every other color except orange. Now the reason that is because in order for you to see orange light has to be reflected off of me. Alright? Orange light is reflected off of this shirt and it bounces back into your eye. That's why you see orange. Not because this absorbs orange, but because it reflects it. That's how color works. Now once it's inside your eyeball, that wavelength of light hits your cones. And those cones send an electrical signal to the brain saying, oh hey, yellow. And that's why we can see color. That's why we perceive color the way it is. And every different color has its own message to send to the brain. Blue is a slightly different electrical signal than yellow, is a slightly different electrical signal than red, is a slightly different one than green, so on and so forth. Every color has its very own signal, and that's how your brain tells what color is what. Now, the brain is really quick at reading color. We're very fast at that, and that's because we have to be. When we were cavemen, imagine being a caveman, and you see, oh hey, leopard. You've got to be really quick at that because it's really, really important that you get away. When you see something that is brightly colored, or say it was a poisonous plant. If we see a poisonous plant when we're cavemen, it's going to be really hard for us to survive if we can't see that that plant is neon green. It's really important for us to be able to see color and to read it quickly. Now, on these next two cards, I'm going to need my dad. Alright. The first test we have today is called the Stroop test. Now the Stroop test is a test of your vision and how your brain interacts with your vision. Since I don't have any small children present, I have brought in my dad. Say hello.
Good morning.
He is going to help us with the Stroop test today. Now what he's going to be asked to do is actually look at these cards that you'll see in just a second, and he'll be asked to read not the word, but the color. Now that's very difficult for the brain to do because the brain actually processes words just a little bit faster than it reads color. So we're going to have to see how he does with a little timer. So let's go ahead, Dad, and I want you to read those colors as fast as you can. Go.
Red, green, brown, green, blue, purple, orange, brown, green, blue, purple, yellow, purple, pink, 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 orange, orange, brown, white, red, yellow, red, white.
Wow. Very fast. Good job. Now that one is pretty easy because as you'll notice on that card, the color is actually the word that it is printed on. So let's see if it mixes up his brain a little bit when we mix up the colors. Let's go ahead and see how he does on this card. Go ahead.
White, brown, blue, red, red, white, purple, white, red, green, green, brown, yellow, tan, green, blue, purple, pink, pink, blue, tan, brown, yellow, white.
It's actually yellow at the end there. That's all right. That's okay. That happens. Now, there are two reasons that that happens, and we'll go over those in just a sec. This phenomenon, as I mentioned before, is called the Stroop effect. The guy who discovered it, his last name is Stroop. Now, judging by this guy's picture, I can't imagine why he didn't do a study on hearing, but, we'll let that go. Now, there's two possible reasons for the Stroop effect. The first is that reading words is processed a little faster than naming colors. We're so automatic at reading, most of us, that it is really, really easy for us to read the word, but not necessarily so quick to name the color. That's why when my dad was on that second card, he had a little trouble when he was naming the color because his brain just said, read the word. And that's why it was a little bit more difficult for him on that second card. The second reason is that naming colors requires a little bit more attention than reading words. Reading, for most of us, is so very automatic. I mean, how many of us in this room have gotten to the end of a page of a book or a magazine or an article or something like that and not remembered what you read? That's a common thing because reading for us is so automatic that we can just go on autopilot. Our brains can go to sleep and we're still reading. But naming colors requires conscious thought. It requires a little bit more attention. So that's the second reason that the Stroop effect can happen. And again, your rods and your cones and your eyeball and how it communicates with your brain is all about what this is. Again, all this stuff has to do with your brain. All these messages and senses and everything send electrical signals to your brain. Now from here, your brain decides what to do with it. And that's really important. Again, the reason we still have these instincts is because imagine like caveman times. You're out on a hunt and you're ready to go. But oh hey, panther. You've got to get out of the way. You've got to do something with that information. I see black. I see movement. Okay? I smell fur. I smell wet fur. You hear a little growl. You've got to do something with that information. And that's what the brain is responsible for. Your senses are responsible for going, oh hey, panther. But your brain is responsible for what is done with that information. In caveman times, our senses were what kept us alive. Imagine if you're a caveman and God forbid you don't have one of your senses. That's going to be really, really hard for you to avoid predators, to avoid eating something you shouldn't, to avoid going places you shouldn't. And that's why those people generally didn't survive as often. The people who survived were the people who had the best senses, were the people who had all 5 of their senses and had the keenest vision and the most acute hearing and the best sense of taste. And they are the ones who lived enough to make babies. And those babies would then have those awesome same senses. And then they would pass it on to their children because they would be the ones to survive.
Ooh, that smell. Can't you smell that smell? Ooh, that smell.
Okay. Now the next sense we have is the sense of smell. And this test is going to be kind of an interesting one for my dad. What he's going to do is he's going to take each of these little containers and smell to see if he can identify the smell that's inside. That is how we play What's That Smell? So, Dad, why don't you go ahead and shut your eyes, and I will hand you the first container. Go ahead and open that up and see if you can identify that smell.
Yeah, that's peanut butter.
Nice. Perfect. Now, the reason that's so quick for him is because that's a very recognizable smell for him. And we are going to see that actually food smells are very, very much more recognizable than other smells. So, Dad, smell number 2. Shut your eyes.
Coffee. I think coffee grounds or fresh
Perfect.
coffee.
Well done, Dad. Very good. That is a very, very recognizable smell. All right, number 3. See if you can get this one.
Is it tuna fish?
It is tuna fish. Well done. Very good. Very good. Go ahead, Dad. Number 4. Now this is going to be the one. Just open it up, and I'm going to go ahead and see if you can smell this one in my hand because I had spray paint to use, and that's going to smell my spray paint. So here you go.
It's a crayon.
Perfect. Well done. One of the most recognizable smells, actually, is crayons. Don't ask me why. Crayons, though, makes all the lists as one of the world's most recognizable smells. Dad, here's smell number 5. This one should be an easy one.
It's an orange.
Of course it is. Well done. Citrus is another very, very strong smell to the human nose. One more, Dad.
I know the smell.
You should. Boy, I can smell it from here. That's
Oh, it's gum.
Of course it's gum. Good job. Very good. Now, you'll notice as he was doing that, I am entering these pieces like they're a puzzle. And that's because that's the way the nose works. The nose works just like a puzzle. In your nose, there are millions of different scent receptors. Now, what happens when you smell something is that those odor molecules fly up into your nose and they go right to their specific spot. Because your nose is like a puzzle, that smell is only going to have one little place in your nose where it fits properly. Now there's going to be millions of odor molecules flying around in your nose, and not all of them are going to get to where they should go, but a couple of them will. And because a couple of them will, when they fit into that one little spot, that sends that electrical signal to your brain, and it goes, oh hey, tuna. Oh hey, orange. Oh hey, crayons. Now that's really important for us to be able to smell different things. Because again, in those olden times, those caveman times, it was really important for us to go, oh hey, I smell food. Or, oh gosh, I smell an animal. And that's really important for us to have that sense because in the day, that's what kept us alive. Now you'll notice my dad was very quick to recognize the various food smells. That's not just because my dad likes food, as do I, but that's because actually the food smells are the most important smells in our brain because, again, those were what kept us alive. When we smell food, that's awesome for us because we can then survive another winter because, oh hey, food. And that's really why it's important for us to recognize food smells. And that's why if you are naming smells, like if you were to name 10 smells as quickly as you could, you would probably most likely have mostly food smells. And that's because those are the most recognizable ones to you. Now our sense of smell is pretty darn good, and that's because we needed it to get to this point. But it's not as good as when we were caveman times because these days if I go, oh hey, pizza, that pizza is not going to come and kill me, okay? If I go, oh hey, pie, that pie is in no danger to my life. So really our sense of smell has kind of declined in the past, 100, thousands of years. However, there are still animals out there, and very common animals, who have awesome senses of smell, much, much better than ours. For instance, we have about 5 million scent receptors in our nose. Now that's a lot. That's 5 million different smells we can smell, and combinations and all kinds of stuff. Dogs have 300 million in their nose, 60 times better than ours. So they can smell things that we couldn't even imagine. And that's why dogs rely so much on their sense of smell. It's because it's their vision. Their sense of smell is as acute to them as our vision is to us. It's very, very important for them. Their vision isn't as important. Dogs are colorblind. They can't see the colors that we can see, but they make up for it by having that awesome sense of smell.